Welcome back to another video by MedGuide. In this video we're going to be talking about the alimentary canal. So what is the alimentary canal? It's a tube which will connect our mouth eventually to the anus, which is where we expel feces from, and it's everything in between. So it's all the organs and the viscera which act on it, for example the liver, the stomach, your intestines, and today we're going to basically take this model apart, look at each of them, learn their names, a little bit about their functions, and talk about some of the clinical problems you might see on the wards. First place where food goes when we eat it is our mouth or our oral cavity, and above it is our nasal cavity. Behind that is the pharynx, which can be split up into three parts: the nasopharynx, the oropharynx, and the laryngopharynx. Then we have our trachea, and posterior to the trachea is the esophagus, which will go on to connect to the stomach. So there's two ways in which food is digested by our oral cavity. Firstly, mechanically by our teeth. So our incisors and our canines are used to rip and tear food, and our premolars and molars are used to grind and chew food. And chewing is known as mastication. The second way in which food is broken down in the oral cavity is chemically. So there's some important glands in your head which you'll learn about in clinical skills. You'll learn how to palpate them, find out if there's any lumps or bumps in them. So that's your parotid gland, which you can feel here, your submandibular glands, and your sublingual glands. And they all have slightly different functions, but the main point is that they produce saliva. So saliva is a lubricating, watery secretion which has some mucus content, and it also importantly contains enzymes. So just so we're all on the same page, normally in biology or medicine, when there's ASE on the end of a word, so A's, that's an enzyme, so amylase. And what it does is a catalyst. So it makes it easier for water to react with the food, and it undergoes a reaction, breaks down that food into smaller, more manageable chunks for our body to digest and to ultimately absorb. So you'll learn in block 3 about cranial nerves. These are nerves that come off the brain and also off the brain stem. They supply lots of functions in the face and functions throughout your body, but particularly in the pharynx, so 9 and 10, the glossopharyngeal nerve and the vagus nerve, they supply, so 9 supplies the sensation, 10 supplies the motor aspect of the pharynx, and if you damage those, you won't be able to protect your airway, so you're at much greater risk of aspiration. That means you can't feel or you can't move your throat to protect your airway, and you're more likely to swallow food. It goes into the lungs, and you can get a pneumonia or other lung infections. So once the food has moved from the pharynx into the esophagus, it's going to begin to make its way down to the stomach. So the esophagus is a tube, which we can see on our model here. It sits posterior to the trachea, and it's not open all the time. It will normally be kind of flattish and closed like that, and then it opens up when we swallow or when we vomit. It's protected at either end by 2 sphincters. So a sphincter is a muscular tube or a muscular part of the body which can close. It can shrink down and close, or it can open, and that allows access of substances into and out of whichever organ it's working on. So once the food has come down the esophagus, we get to the stomach. So the stomach is a J-shaped organ, and it's essentially a bag which will store food, and it also it can contract and it expands. It expands to store the food, but it can also contract down, and it propels food against the pyloric sphincter at this end, which will again mechanically break down any food into smaller pieces. So just some anatomy. The top part here is called the cardia, the part closest to the heart. The fundus, importantly on x-rays you'll be able to see this. So in a patient having an x-ray where they're standing up, you'll see a line and above it will be black, then there'll be quite a straight line, and below it will be white where they've eaten. So that's the fluid of the stomach, and then the air above it, and the different densities produce that, and that's the fundus, normally the part furthest away from the exit. We also see a fundus in other things like the gallbladder, and we'll come on to that a bit later. Okay, and you're also this year going to learn about the blood supply of the stomach and its innervation. So from the stomach we enter into the duodenum, which is a sort of curved tube. So the stomach has sat here, and if we take that off, it enters into a curved tube, which the pancreas nestles its head in down there. And it's called the duodenum because duodenum means 12 fingers long, so 12 finger breadth. And importantly, that's where the accessory organs, so our liver, also our pancreas and our spleen, they enter by ducts. So they secrete substances, and they then have ducts which will enter into this tube. So the small intestine, the duodenum is the first part of the small intestine. It will enter into that tube, and they'll have enzymes, they'll also have bile produced by the liver. They'll enter in, and they'll again help with digestion. So if we look at the image on the slide, we can see here the outline of our liver, and this is the duodenum, so that first part of the small intestine. We see the gallbladder. Over here we'd have the pancreas, and then you'd also have the spleen over here on the left side of the body. So these are some of the tubes that I was talking about. So the liver, for example, the liver produces bile, and that's important for the digestion of fats. So it's a surfactant which emulsifies the fat and makes it easier to be digested. That bile will enter into the right and the left hepatic duct. Those ducts will come together and form the common hepatic duct. And then that's connected with the cystic duct, which connects the gallbladder to the other parts of the tube. The gallbladder just stores bile. Gall is another word for bile, so quite literally the bile bladder. In our body we have other bladders, obviously the urinary bladder to store urine. The gallbladder just means a place to store bile. And when we've eaten a meal, hormones will act. For example, one you'll learn about is CCK, cholecystokinin, and that causes gallbladder contraction. So the gallbladder contracts, and bile is pushed into the common bile duct, and then that joins with enzymes produced by the pancreas, draining down the pancreatic duct, and here we have the ampulla of Vater. So where the common bile duct forms the pancreatic duct is the ampulla of Vater, and that enters into the duodenum at the major duodenal papilla. The importance of this is the food that we've swallowed and eaten. It needs to be. We can't break it down on its own. It needs to have enzymes and different things added into it, like bile, and that helps the digestion process. So from the duodenum, the food will begin to enter the other parts of the small intestine. So that being the jejunum and the ileum. So if we imagine this on me here, our jejunum is the first part it comes to, and will end up at the terminal ileum. Now one key fact to know is that vitamin B12 is absorbed in the terminal ileum, comes up pretty much every year. And if we then open this up, where the small intestine meets the large intestine, that area is called the cecum. Inferior to the cecum, here, is the appendix. So this is what becomes inflamed in appendicitis and is quite commonly removed. It then works its way up the the ascending colon, along the transverse colon, and down the descending colon to the sigmoid colon, sigmoid meaning S-shaped. It then is stored, the food, by this point it's feces, is stored in the rectum, and then the defecation reflex causes the expulsion of the feces out of the anus and into the external environment. So in the small intestine we have lots of transporters, And in block 1, so in September, you'll learn quite a lot about these transporters, and they're really important for knowing how in pharmacology, so when we're learning about the different drugs, how they work and what the different, for example, the diuretics, which cause us to urinate more, they have different effects on the transporters. And when we have a good understanding of those, we can understand how the drugs work. So it's linking the pharmacology with the anatomy. By the time we've got to the large intestine, essentially we only absorb water in the large intestine. And yeah, that's what I want to say really. Otherwise I'm going to lose my streak. So as you can see on this model here, if we take away the lungs, what the f was that?